found those double angle identities, which up here we have them all. So sine 2 theta, right, which was theta plus theta, right, when the u and v are the same. That's the double angle, which equals 2 sine theta cos theta. Cos of 2 theta is the same, right, as cos of theta plus theta. But because they're the same, that's why we write 2 theta. Now notice all three of these are the same. Sometimes we're going to want to use cos squared minus sine squared. Sometimes we'll want to use 1 minus 2 sine squared. Sometimes we'll use 2 cos squared minus 1. Just depends on the problem. We can use any of them. And then for tan of 2 theta, we have 2 tan theta over 1 minus tan squared. Let's look at this first problem. So for this example, it says, given tan theta is negative 3/4 that lies in the interval pi over 2 and pi, find the exact value. Hint, you know the value of tan. Draw a triangle in the correct quadrant and expand the following using trig functions and double angle identities. Find input values and evaluate. So let's first draw our triangle. So we know SOHCAHTOA. We know that tangent is going to be the opposite over the adjacent. I know that my triangle that I draw has to be between 90 degrees and 180 degrees. So we can draw that over here. So 90 is here, 180 is here. So we know this triangle is over here. Theta is on the inside. So we have opposite is 3. Adjacent is 4. Now notice there's a negative here. Okay, don't assume it goes with the 3. I throw the signs in at the very end based on our direction. So we know that this is a 3, 4, 5 triangle, or you could use Pythagorean theorem, right, to find 5. 3 squared plus 4 squared equals c squared. To the left is negative, so I know this has to be negative 4. Up is positive, hypotenuse is positive. Now that we have our triangle set up, let's head to the problem. So sine 2 theta. Looking at our formula above for double angles, sine 2 theta is equal to 2 sine theta times cos theta. And this is 2. So sine of theta, sine is opposite over hypotenuse. So opposite of theta would be 3 over hypotenuse would be 5. Then we have cosine of theta. So cosine is adjacent over hypotenuse. So the adjacent would be negative 4, hypotenuse would be 5. I'm going to put the 2 over 1. And we'll multiply in the numerator. So 2 times 3 times negative 4 will get negative 24. And in the denominator, 1 times 5 is 25. We can't simplify. Cos of 2 theta. So I'm going to look at my double angle identities. I know that cos 2 theta is equal to cos, you can write it as cos squared theta minus sine squared theta. So if I look over here at the triangle, I know that cosine is adjacent over hypotenuse. So again, cosine's negative 4 over 5. And we're going to square that. Minus, we know that the sine is opposite over hypotenuse. So opposite was 3. Hypotenuse was 5, and we're going to square it because it says sine squared. So negative 4/5 times negative 4/5, right? Negative 4/5 times negative 4/5 is going to get us 16 over 25 minus 3/5 times 3/5 will get us 9 over 25. So our denominator is 25, and in the numerator we have 16 minus 9, which gets us 7. Now let's look at tan 2 theta. So tan 2 theta we can write Goes in. Okay, tan 2 theta, we can look at our identities and we can write 2 tan theta all over 1 minus tan squared theta. You can look at those formulas above. And looking at our triangle, we know that tangent that was given, opposite over adjacent, was negative 3/4. So in the numerator, we'll have 2 times negative 3/4, right? Tangent, if you looked at that triangle that we just drew, this was negative 4, this was 3, and this was 5. So they gave us tan, but again, tan is opposite over adjacent. So 3 over negative 4. So negative value 3/4. So 2 times negative 3/4, 1 minus, so tan squared. So negative 3/4 is the value of tan theta, and we're going to square it. Let's simplify in the numerator. So we have 2 times negative 3 is negative 6 over 4, which is going to become negative 3 over 2. Let's do this. And then in the denominator, I'm first going to write 1 minus, so it's negative 3/4 times negative 3/4. So we're going to have 1 minus, negative 3 times negative 3 is 9 over 16. We need to multiply the left fraction by 16. So we'll have 16 minus 9, so we get 7. Over 16. So then we have numerator divided by denominator. So the numerator was negative 3/2 divided by our denominator 7/16. Change division and multiplication, flip the fraction on the right. I can cancel 2 out on top and bottom. So numerator negative 3 times 8, we get negative 24 over 7. When it says what quadrant does 2 theta lie, we have to look at A, B, and C. So A says sine of 2 theta is going to be a negative number, right? Negative 24 over 25. So sine 2 theta is negative. Cos of 2 theta is positive, right? Positive 7 over 25. And tangent is also negative. So we're going to come over here. We're going to say all students take calc. So let's first look at sine 2 theta. So it's saying sine of that 2 theta has to be a negative value, meaning the triangle can't be in first quadrant. Sine is negative, so it can't be the second. Okay, check. So we've taken care of sine being negative. If cosine 2 theta has to be positive, there's only one option left, the fourth quadrant, because cos is not positive in the third quadrant, only tan is. And if we pick the fourth quadrant as our answer, tan 2 theta is negative there. So our answer would be the fourth quadrant. Now some of you might say, well, the original problem, we had an image in the second quadrant. We did, however, it just said tan theta, right? It said tan theta. But the last problem says in which quadrant does 2 theta lie, not just theta, okay?